Ba-ba-bum, ba-ba-bum-bum. Okay, hello, good day everybody, and welcome to our class on CS machine learning, or machine intelligence, whatever it is called. It is main, CS main. And today in our program we have a special lecture, because this is a guest lecturer who is coming from the very Gibraltar. So from the place, the only place in the world where monkeys allowed people to live together with them. So our lecturer today is Kirill Korotkov. Hero is not only the person with whom I was working for many years, but also right now he's a senior software and data engineer in one of the, I would say, biggest gambling companies in Gibraltar, maybe also in the world. But I mean, this is up to you, Kirill, to tell about yourself a little bit more. So, guys, please welcome Kirill. Listen attentively, ask as many questions as you want, because I mean, after that, I won't be able to answer the questions because only he has this secret knowledge. I know nothing about streaming and data lake houses. I mean, I know about data lakes, but data lake house, I hear for the first time, I think. So, Hiro, please welcome. The floor is yours.
Woo!
Hi everyone.
Jesus Christ. Saverio, I hope that you are alive because, I mean, that was something. Okay, great. So, Kirill, please.
Yes, hello everyone. So, yeah, I'm a senior data engineer, work in at Padriana Limited. Yes, so we make software for gaming. Um, yeah, um, so today I'm going to share with you some, I hope, very interesting examples how you can apply streaming in work. So I will use examples from my experience, and hopefully it will be useful for you. So, all right. First of all, I hope first of all I think better to ask with what you already had experienced before. So are you familiar with such things? Anybody familiar with Spark or with any other streaming tools or platforms? Have you used anything like this before? Like, for example, Spark or Flink, maybe.
We're basically pros. Yeah. We used
Sorry?
Spark, but yeah.
Okay, so you use Spark, so you have some knowledge about Spark.
I mean,
Okay.
Kirill, I think I can give a comment that guys know Spark, that they didn't use streaming with Spark. So
Okay.
at least they know that there is Spark, there are data frames in Spark, and so on and so forth. They even know about RDDs.
Okay. Okay, nice. So, all right. And anybody familiar also maybe with Docker or worked with containers with Docker? So it will.
In general, guys, today, if you are like, let's say, without cameras, you can make reactions. For example, you can make this reaction like the thumb up, or let's say to say that thumb down. For example, I would use thumb up because I have used Docker. Yeah. So, for example, somebody might use the reaction thumb down. Like, okay. Oh, Saverio, do you want to ask something? You have raised your hand.
No, I just only see the Haben, but no, not the thumbs up.
Okay, good. Yeah, but I mean, in general, feel free to say that yes, use. Oh, you see Tobias use. So I mean, like, yeah, I mean, I think like in general, people know that, let's say, Docker is something that makes your system reproducible on any machine, kind of.
Yes, yeah. So just to give you some overview, what I'll be talking today. I have here in GitHub. I pushed it recently. So a project where I will go through examples with you together, and you also can clone this project, and later on we also will do some practice with this. So mainly, yes, I have here slides, but mainly I will go through this project where I will use Docker Compose, and show on examples what we can use there. So, okay, so let's start. So I will tell you about one, well, there will be one thread through this whole discussion. It will be about this one case scenario. I called it like retaining in online shop. It's based on one of the things that we had to solve at work, and but it's more like a general case scenario. So it can be applicable to any other cases. So first imagine that you work in a company in online shop, and you have some customers who buy and order products from there, but they tend to disappear in time, which is called churn. It's this thing when customers slowly stop using your product. And well, there are a lot of potentially valuable customers, so we would like to retain them, meaning that we want to leave them on site and continue buy stuff. So this is called retention. And we would like to make it, well, in our case, we would like to make it as fast as possible usually. So, all right, so this can be solved in many things. It can be solved many cases. You can find how to solve it. You can make, like, I don't know, cold emails. You can make newsletters, so you can make advertisement, well, so on. But like, let's see like this particular example where we would like to identify the most valuable of them and retain them with actions. So imagine that in this online shop we have just two tables. Well, just customers, where you have data about customer, and orders table with all their buying and information what they bought. And well, basically just these two tables. Here I have, so in this project, yes, so I have it locally as well. So this is a project that I cloned from GitHub. So here I will use Postgres database. This is one of the most widely used databases, so it's open source. So we use this as an example. So here is the structure of these two tables with a bit more columns as well. So this is the structure, and well, because, well, let's think that, okay, so we have come up with some ideas. So company had decided that, yeah, we should retain them as fast as possible. So it should be like in real time. So we should apply some streaming application. And well, basically, analysts had already decided what we should do with them, how we should identify the most valuable and with high risk to churn customers, right? So we have some strategy. And basically, let's try it right now. So so I have here so I opened a terminal here for this project, and I'm gonna use Docker Compose. We'll go also through how to configure it and how we can run it together. Let's right now just start one example. So here I have, if maybe you're familiar with Docker Compose, it's well, a tool can be used together with Docker where you want to run several containers at once and configure them. So here,
Kirill, sorry. Just, I mean, I know that the guys are very brave and they are like putting their thumbs up saying that yes, they know Docker, they know etc. But I think still it would be really nice if you just briefly tell them like why you might need several containers, what is container? Yeah. So I mean, just like a brief recap. This would be, I think, useful.
well, okay, yeah, nice. So container is well, it's just, let's imagine like isolated process on your computer, like very isolated, like virtual machine, not really like virtual machine, but very isolated process. And there you can, and then you can set up or shut down your applications. And they also can, well, they can also speak with each other, obviously. So if you have API or database, you always can connect to it. So short speaking here, this is the configuration how to start up Docker Compose. And here is written two things. So Postgres database configuration, it's just simple database that is available from open source, so it's already pre-configured. And it says here that we should initialize, well, our two tables. And the second service is, it's called here test data. It's, well, here it's just a separate app that produces some fake data. But let's show it on example. So to run it, we just need to run Docker compose up and specify the file. So it's lecture 1, lecture example 1. And we can also specify that it should run in background mode. It should be parameter D. So let's just run it. Oh no, yes. Compose. This should go after. Yeah. So, and here you see that the two things, they are starting up. So they are both started, Postgres and test data. So if we run Docker compose, so basically again, same command, but with ES services, we know that there are what services we are running. So here is and Hive Metastore. Don't look at this one. It's just was testing. So we see these two services. They are up and running. Well, if you look into configuration, you will see that Postgres opened on port this one 5432. So we can connect it. And also here is written well, user and password. So we can connect to this database. And here is also a small example command how to connect to it. So we will run it and we'll try to connect to this database from command line. But this will, yeah, but there is a bit more complicated actually. Command. Yes, actually I need to run it like this. So because I don't have this PSQL command installed on my computer, so we can actually run directly from Docker. So from Docker. So here this command is executing this. So basically here it's written like Docker should execute command inside this service called Postgres and execute the following command. And the following command logins to database. So now I'm in database, and it's command line interface without, well, user UI interface, but it's still very well, very functional. So let's see. We can list what tables we have right now. It's these two tables, customers and orders. We can try to select what data we have from these tables. Let's see what is inside table customers. Okay, so we have 5 customers right now there. And also let's see how many orders do we have. Okay, so we have 77 orders right now. And so, well, just well, question for you. So right now we have this database, right, with orders and customers, and we also have, well, we can see, well, what we have. Well, we have all the columns that we need already, and we have this condition, like, okay, so this is given to us by a data scientist or analytics, so that we should identify these customers. How would you approach this thing, task? What will you do? Just what do you think? Having just this minimum available resources for you. So anyone? Well, so what you could try is if you're familiar with SQL, right? You could try to write some SQL query that will find such customers who meets these criteria, and well, basically, and just try to do something with them. But having just well, SQL to write SQL, it should be already well enough here, right? So, and here I have in another file, I have an example of such SQL. It's inside Postgres folder. So this is just an example to illustrate, well, like, so we have some kind of complex SQL query. It follows what is written there in this slide. So basically, it gets customers, it gets their orders, which are also cancelled, and well, calculates these things like this. They should have at least 2 orders. They should have cancellation ratio of 30%. So it should be recently done. Last order should done like very recently. So it basically just calculates it. So let's copy this SQL, and we can copy it right to the Postgres here, and just run it. So I click enter, and at the end here is the answer. So right now, well, as we've seen, there were just 5 customers, and well, none of them actually meets this criteria right now. Yes. So okay, so problem seems solved right now because, well, we can identify them, and well, so far there is no any customers admitted, but we already can find them, right? And potentially we can maybe run it, I don't know, every 10 seconds, for example. We can schedule this to run somewhere, this query, and against the database to run every 10 seconds, right? Well, and actually this can work, but usually, This is a very simple, small example scenario here. But usually it's we would like to have more approach where, well, imagine that we have millions of customers and millions of orders, and they do them every second. And in time, like maybe it will work initially, and database is fine. There'll be no pressure. But maybe later in time, so I don't know, analyst will come up with some new idea how to do it, or he will like to have different categories of customers, right? So in time, this solution will need to evolve, and maybe in some future you will see that the database, well, that you will run this complex query against your main database, and it will be pressured by it, and well, nobody wants to have a high pressure on their main database, right? So what is another solution here could be is to have a copy of this data somewhere else. So because it's right now it's just one, this is just one single Postgres database here, but we can have, so, and let's see also, I think there is already now, yes, so there should be now more orders. Yeah, okay, so there are now 200 because it's constantly adding new data. So, but so we would like to have also like a very like the very latest copy of this data. And there is in the field there is established approach how to do it. It's called CDC. So it's a way when we would like to have the same database, but well, somewhere else. So, or it's also called replication of data. Usually it's used for just to have, like, you would like to have this second database running. Maybe you'll spin up here like Postgres 2, and you will configure it that it should copy this data from here to here on a regular basis. But well, we would like to have some more sophisticated approach. We'd like to have it also because, well, we have just one task right now to find customers that we would like to retain. But also later on, we would like to have more analytics done on it, right? We would like to have complex analytical queries and so on. So we would like to have some data warehouse or data lake above on top of it. So in this case, we would like to have not Postgres, but something else. But we'll see what I mean. So to establish this, it's usually common practice to use these two things I mentioned here. It's called two things, two tools, Debezium and Kafka. Well, you're probably not familiar with them, but this is just a streaming platform. And I will show this example. Let's exit from Postgres that we have. Let's now stop our Postgres and as data. So we should run the same command, but instead of up, we should run the command down and add an additional flag v. Okay, so it stopped it. And now I will spin up a second example. Up D. And here is a bit more well, more things running. So you can see here is, well, same thing. We had Postgres and also test data, but there are added few things: Zookeeper, Kafka, well, three things: Kafka Connect, UI, and Debizo. So it's, yeah, there are lots of stuff added, but most important things that we need from here is that we added Kafka service. So it's just another container for Kafka. Everything else is just an addition to it, just to establish this streaming from this Postgres to Kafka. And it has user interface, so we can open it. So we saved it here, so it's a link. So it's, yes, so you can see, so it's running on port 8090. Okay. So I have connected to my local Kafka that I just started. If anyone familiar with Kafka, have anybody worked with it before? Okay. So just to explain, so Kafka is a streaming platform, and it has, well, it has two things. It has topics, which are events. So you can publish new events and you can subscribe to them. So these events here, you can see topics on the left side. Just, yeah, well, just you to know, so it's already automatically configured. We already have here two topics. These other topics are not really needed for us. They are named the same as our tables: Postgres public customers, Postgres public orders. These two tables. So we can open them. We can, yeah, overview, and we can open here tab messages. And here we have the data. So as before, we have 5 customers here. Here they are in a bit different format, but they are in JSON. But the data here is the same. So if we just scroll down, we see here, here is a payload, and the same data is in Postgres. So we have columns, customer ID, name, birthday. They might be in a bit different format, but still it's readable, and we can process it. And so we can see also that, yes, this is orders table. We can also see that now, because I restarted, data also was wiped out, but it's populating again. So now you see there are 82 orders and they are coming up. So every time when the new order arrives to Postgres, it will also appear here as a new topic here. So all updates will come to Kafka as well. And so having this streaming platform, we can now we can start doing some other data engineering stuff, but now we'll not be afraid that we'll pressure our main database, our Postgres. And we can add more and more things here without being afraid that we will break something or in our main database, anything. So, yeah, somebody raised a hand.
Yes, sorry, I found a way how to unmute. So regarding this, sorry, it's a bit echo here. Regarding this Kafka and all this data seeing there, is this also persistent?
Sorry, I hear echo. I heard that is it persistent, right? This is the question.
Right. Is Kafka also kind of in a DB now? Because obviously you store all this data here, and you kind of it's available, right? So
Yes.
are you replicating in there as well? So we have a kind of a third place or a kind of third DB now, or sorry, a data storage or what?
Yeah, you're right. So now we have like additional storage. That's absolutely right. So we can treat it as database. You're absolutely right. It's even possible to treat it as database because it's also running in. It also has a disk. So this data here it's also stored in Kafka. So if we'll shut down Kafka and start again, so something is saved there. So it also will be available for us. But it has if comparing to Postgres, it has a different purpose. So in Postgres, data is also there, but in Postgres, it's easy to add new data. It's easy to write SQL queries, like to make connections between orders, so we can join orders and customers, right? But here, Kafka has different data structure. So we cannot do SQL query against Kafka. We cannot join these two things, customers and orders, right? We can only subscribe to them. So we can only or publish new data. So if we want to read, for example, if we want to replicate this complex SQL here, we are not able to replicate it right now yet. Yet we are not able in Kafka because we'll need to read all this data from customers, from orders, and do our processing by hand, let's say, with some code. But it's very useful for these situations where we would like streaming data. So we would like to subscribe and we can instantly get new event. So after we subscribe to it, we instantly get new event for orders, for example, right? So somebody did an order, we instantly get it if we subscribe to it. But the question,
I was only asking this because there was a big debate in our company about in what extent we can use Kafka, because we are using Kafka to connect the core data or core database with cache layer, and we had always a debate if the persistent data can be, or persistent data can be used also Kafka, and but our question was mainly referring to the how much if we keep the data longer in the Kafka, for example, more than 2-3 months, if this has a direct implication on the Kafka performance or not. And we were not yet able to non-functionally test this feature. So we assumed yes, it has, as long as you retain data, as slower the Kafka streaming is, but yeah, not yet confirmed.
Okay, yeah, that's a good question actually. Yeah, about retention of data in Kafka. So I myself did no practice about how long it's efficient to keep, but usually as I've seen before, usually it's data stored there for a short period of time, like maybe for a week. Well, depends on data size, right? How much data do you have? But usually it's used for not very long period of data. So
current config what we have, it's 1 month. In front banking or front data in cache layer, we have 3 months. So we agreed for now, just for security reasons, no functional reason, we agreed to keep it shorter there. However, we have solutions which are relying on the Kafka data intention data, meaning a lot of times when cache layer is being refreshed or become unexpectedly down, then we don't go to the core back or to the database like Postgres is here. We always only go to Kafka. So if it is within 1 month. So.
I see. Well, I would also suggest, I don't know what your case, but maybe suggest if you need a cache, like very fast retrieval for data, it might be good for use not Kafka maybe, but like Redis database, or there's also there is another database called memcache. So it's the other things. It's like for key value storage. So when you have key and value, but it depends on the situation. So, but yeah, to summarize, yes. So Kafka is good for subscribing and publishing events, and yeah, better to keep not very the whole. Better to configure it to delete all data. So if we have like more than week or more than some time period, more than month, better to delete data from there because it's not needed anymore usually. All right. Yes. Okay. So I have stopped. Yeah. So um, so we showed how we can configure the streaming. So we can configure the streaming of data from Postgres here to Apache Kafka. And now, next question is, okay, so we have now the streaming platform. Now how we can start getting any value from it? Let's move forward to another example. Well, just, okay, again, question for you, like, what would you, if you have it, like, what will you use here? If you think, like, how do you approach this? What is, what are your ideas here? Okay, well, I will start. So I will show you example with one, well, solution with Spark, which is, so Spark is a very well established tool for processing a large amount of data and also for streaming. But also I must say that before, so for my case, I used another tool as well called Flink, also Apache Flink. It's another tool, but they are very similar. So there are many options how you can try to implement the streaming your streaming application, but it always depends on your scenario of what you have right now. So, for example, in our case, it was initially it was good to use Flink because it's like very fast. It's advertised as even faster than Spark. But then, because we are using in our company, we are very relying on Google Cloud platform, and so all our services running in Google Cloud. And initially it was good because they have, so in Google Cloud they have service for Flink, and it was very useful. Well, it was very easy to use it there, but then they decided to stop the service, to stop the support for it. So then we decided to switch to Spark after this, because in Google Cloud there is a service for Spark, so it's called Dataproc. And so, well, having it there, all infrastructure already managed by them, so we don't have to think about it much. Yeah, just a small note on this. So sometimes choosing the tool is very well dependent on what you have right now as your currently resources. So in Google Cloud, it was really just easy to switch to Spark. Okay, so I have shown this example with Kafka, how to start up Kafka. Let's put it down. Let's start. Let's start another one. So now I will start the full example. So now I will use this file, Docker Compose, and again I run apt-d, and now there is well, there are much more services. I will go, well, to summarize, so it includes the same things that we've seen right now, but also it includes now two more things. It includes now Spark cluster, very small cluster, just for our example, and HDFS. So yes, so maybe you already worked with Spark, so probably you already know also what is HDFS. It is distributed file system. So it's also part of Hadoop. So Spark, Hadoop, they all together part of one umbrella of tools. And this is basically place where we will store our data. Let's see. So how it's starting? Yeah, it started. The services. Yeah. So now we have now more services, but what most important here is that we have Kafka, we have our Postgres, and now we have Spark nodes here and this HDFS nodes. Yes, so before speaking about Spark, I think, yeah, it's also worth to tell about the HDFS. We can even see, so it also has user interface. So here it's console to manage HDFS, but we are most interested in this thing. So here we have tab utilities, browse file system. And here we can see, because it's distributed file system, it's not like simple folders, but here we can see in this console the same way as folders. So here we have some folders called user. Well, right now they're empty, but we'll start populate them very soon. So, and here we have the folder warehouse. So speaking of HDFS, it's very common. It's a very common tool to use as a data lake. So, and I wanted to clarify a little bit what it's all about. What is this data lake? So we also have the terminology data warehouse. And to speak shortly, it's just the difference is what we store in data. So if it's data lake, it's usually meaning that something is unstructured. So we have some raw data, maybe we have, I don't know, videos or audio files, or we have any kind of data. So if we have this any kind of data where we don't have any structure, it's called data lake. That's just simple. That's it. If we stream some raw data that later on we'll use for processing, and usually it's I don't know, maybe it's prepared for machine learning, or if you want to train a model based on videos or images, and data warehouse is structured storage. So basically, when you have already tables, so the same as in Postgres, so you have tables, you can run SQL queries against it, and usually it's very optimized for large-scale analytical queries where you want to scan the whole data, to calculate statistics, and so on. And just to give overview, what usually is used across the field is data lake. So on left you can see the most known, okay, you can use HDFS, or you can use cloud solutions like cloud storage, or as Amazon S3 is the most well-known things. Or an example as for data warehouse, it's basically a database, right? But for analytical purposes. So you maybe know Databricks or Snowflake, maybe you heard. So these are most known things. Also, there are like cloud, like BigQuery, Google Cloud, or ClickHouse. So there are many of them. Just examples. And usually when you choose well, it's always when you need to choose where you need to store it. It always depends on your actual case. So as I said, in an example, so in my company, we use mostly Google Cloud, and it was very easy to use Google Cloud Storage as data lake for this data. But that's as we moved forward with solving this task, we found out that it was higher latency for writing and reading the data from there. And then we decided just to use this Hadoop HDFS because it's already included. It's already included in their Spark solution. You can write it right there, and it's very fast. And so it was much easier and much faster. Yes, so that's why we choose HDFS right now. And just to give also some small overview. So we have this data lake and data warehouse, but also there is recently, well, more common appeared a term called lake house. So basically, it's kind of a combination of these two altogether. It's when you have some, so as you've seen before, so in database, data usually is stored there inside database, so you cannot access it another anyway. So you're locked in on your database. But people just came up with a solution that okay, we have lots of data, we know it's some structured, so let's make it structured in this data storage so any database can access it, and then we can use it anywhere. So this is approach called lakehouse. When you have data stored in one of these places here, like I showed HDFS, Google Cloud Storage, but already very structured, very good structured way. So any actual database can actually connect to it and you can start making SQL queries on top of it. So and here is a few examples what it can be. So there are open source like Delta Lake, Apache Hudi, and Apache Iceberg. Okay. So here is also again, so which one here to choose? So you might not, well, quick answer here is the best for our use case. The best way is to use Delta Lake because it's already built in, well, not built in, but very well integrated with Spark. It's very easy to use with Spark. It's already just install one library and you can use it. While with other two, there are more a bit complicated things. Okay. So we have we have now our place where we would like to store our data, HDFS. So we have already Spark running. So yes, so we can also see it here as well. So it has also console, but nothing here yet. Let's just try to test small example. Like to test that we have a working environment. So here I copied this command. It's basically what it will do. It will submit a new Spark job. And as you see, it's located in folder up test hdfs, hdfs.py. So it's here. So this is our small health test. It's just basically we'll try to write and read from HDFS some 5 random things. So we copy and pasted it here, and it submitted a job. It writes lots of stuff. Well, it's related to Spark. Not very useful for us, but if we navigate back to our Spark history server, no, yes, actually I had to. So I submitted the job. Has not appeared yet, but it should soon appear. Maybe I will open in another. Okay. We'll open another. Yeah. So yeah, we can see it in another console. So here we can see there is one completed application, and it's named as well, name HDFS test. So we see that it's completed successfully. And if we open again our HDFS, so if we look in the code, you can see that we write to this folder TMP range 5. So here it should appear. So yeah, so here we have this range 5 folder, and it's CSV2 CSV file. Well, it's 2 because Spark is like distributed system, so by default it tries to make several workers, and it will write separately into several files. It should be just 5 numbers, but well, it decided to split them to 2. Yeah, we can. No. It's well, yeah, it's because I have some wrong in my DNS, but okay. So you can trust me. There is just 5 numbers in this CSV files. Okay. Yes. So this was just trying to write some data, but now let's do some more complicated example. So here I have some code prepared. Now it has more stuff included, so we'll now write. So let's go together through this code. So I will start a streaming application, which will run it will run as micro batch approach. So it will run as like every 10 seconds, it will spin up and pull new data from Kafka and stop, and then again in 10 seconds. And then it will write data to this TMP customers table into Delta table now. And here we need to create a Spark session. It's always needed for any Spark application, where we just need to set up that we use Delta Lake. These 2 things are just required to make it work. So then we create this Spark session. We additionally specify what we have in our data. So as you've seen before, we had in Postgres, we had a table. We could select columns from it because it's already known what structure it. But after we pushed the data to our Kafka, I closed already. Yes, it's here. So now it says JSON. So there is no structure. But so we need always to specify what we have inside here. As you can see, we have this JSON, and inside we have key payload, and inside payload we have the actual data. So here we specify it. So inside payload we have these column types. And well, here's the function. I'll come to it a bit later. And we create configuration for reading from Kafka. So we specify that we read stream, in order to make it as a stream application. we say that it's Kafka. We say where our Kafka is located. This is the address. And then we say that we just listen this one topic called customers. And then we say that we need to run it, like then we need to write this stream. And well, here it's specified it's every 10 seconds. And for each, so it's micro batch. And then for each batch, it will execute this function that we have, Python function. And then we start it and it runs, well, forever until we stop it. And here we just get this function where we get the batch. It is in data frame, in the Spark data frame. Spark data frame is, well, if you worked with pandas before, it's almost the same as pandas. So it's just table object. And you can execute many well, it's the same as in pandas. There are a lot of useful built-in commands. You can make statistics, you can make a calculation. So for example, here we can make a count, just how many rows we have there. And we just select then what we would like to take from this, because as you've seen in the Kafka, there is other lots of not really important information for us. So we just select it and then only our columns, and then we write it to our data lake into Delta in a Delta table format. And that's it. So every batch basically, and it's append. So now, so if we started, I prepared here a comment how to do it. So I'll copy and paste it to clear. So copy and here. But I need to call it streaming right. Delta. I have just prepared here. You may see that it's again. So I'm here. I'm executing a Docker command inside this. Now it's inside this container, and I am executing a bash command. But well, it's bash, but because it just was easier, because to submit Spark job you need to specify additional things. You need to specify here also where checkpoints are located. It's another topic as well, but so just I prepared the script to making it easier to start this job. And then we specify that we would like to run this Python PySpark job right to Delta. So it's starting. It also right now it downloads some dependencies because it needs for Delta, it needs library for Delta, and for Kafka as well. For Kafka, it's also need additional library. Okay, and now we can see in logs. Yes, here's now starting the logs that I have added. Yes, so it started, and yeah, you can see processing batch 0. And there are 5 customers here as before, so always there's just 5 customers. And you see there like some glance of this data, so the same as in Postgres. Well, so as of now we don't have anything here because right now, but let's show an example, like what will be if we because for this I will start a new terminal. I'll go to the same project and let's try to insert new accounts to Postgres. So let's Yes. So here I execute in the separate window. I log into Postgres as we did before. So I'm right now inside Postgres, and here I have some examples how to add new customers. So let's now add 3 more customers. This is Postgres SQL. So now see, so now if I press enter, yeah, so it inserted new data. Yeah, you see, now it triggered new batch. And now we see them here as well. So our streaming application found them, printed and written to this table in HDFS. We can even go and look in HDFS. So let's browse again the root. So it's inside this folder, TMP. Now we have these customers. And we have this, well, this is the format of Delta table. It's using Parquet format. Does anyone know what is Parquet format? Okay, nice. Yeah, so it's well, it's a stable format, but more optimized for tables. It's better than CSV. So very good for storing data like here. So, and here is we have, well, additional folder for Delta. Here is just additional information about history of changes of the data. Well, you can see there are 2 things. So there appeared just 2 operations, initial one, and then we inserted. So it keeps track of all history here as well. That's just basically how this Delta table works. It adds, well, as we add more data here, will appear more Parquet files and more info logs of what was added, or was maybe something was updated or deleted. So it's all tracked here. Yeah. So any questions so far? Okay. Now, okay, so let's stop our streaming job. Yeah, I just interrupted it. It's some exception, but it doesn't matter. Also, just yes, so just to show that it's also appeared here in the Spark master console, where you can also, if you need to, usually it's needed if you need to debug your application, you can come here and see information about stages of your job here. Yes, I wanted to show you a graph of our job, but it doesn't appear here for some reason today. Okay, maybe later it will appear. Okay. All right. So okay. We done a simple example with just writing of new data, but now let's well come to our final target. So we would like to make some more complicated calculations of it, right? What we can do? We can just, well, so we have this Spark. We can write, well, there are many functions that we can write. So you can import here functions from PySpark SQL. There are many of them. You can make aggregations, you can make joins, and so on. But and write it all in this code, in Python code, which will be all right. So, well, but we can also do it as well in Spark. Actually, it's supported to do the same thing in SQL, the same way. So as we did here, our initially initial example where we calculated lots of stuff, right, in Postgres, complex SQL query, we can actually do the same thing, well, more or less the same in Spark as well. So how we can do it? Here is another example. So the full example called retain customers. Basically, it just do several things, 4 things. It gets the data the same way as from Kafka, then it writes them to the Delta tables, Delta Lake, and then it reads them and also reads new data from Kafka and executes SQL aggregation on top of them. So let's go through it step by step as well. So we now have so before we had just one table now, but now we have 3 of them. Now we have customers, orders, and also we have the final table called risk analysis, and checkpoint. This checkpoint is for Spark streaming is just an additional safety measure. So you seen here I had the running application and now I stopped it, right? But as long as right now it's already worked, so there appeared new topics appeared in Kafka so far, right? Is it not working? And if you have checkpoint, it makes it easier to start again from a previous part, from when you stopped. So now if I will thread checkpoint here and I start it again, I will start from previous point in time in Kafka. So and replay all the data again, which is very convenient. Okay, so again we here create Spark session. We have here now schema for orders table as well, and we have this SQL. It is the same SQL, but few functions is here, just not like in Postgres, but in Spark syntax, but just very few with this Unix timestamp. So, and here we have this one again function for our batch processing. But now, in this case, now we listen for both topics at the same time, and we can subscribe to several topics at the same time. And here we can just basically split them when we listen, so just filter. So one batch is divided into 2. We can then count how many of them. Again, we do this extracting the needed columns for us. We write them, write as well for orders, and then we execute this SQL. So we read recent data, we put them into so-called, in Spark it's called views, so temporary view, and name them recent customers and recent orders. And now it's data available in SQL, so we can now run our SQL on top of this data that we recently read. And then we can make some additional, on top of it, some additional logic, like, oh, let's select only customers that we would like to react on them, like who was at risk, and print them, and save to table, another table. And here the same as we've seen before, but now here's just 2 topics now, subscribe to customers and orders. Okay, now we can start it. Let's start our, but now we need to replace it with delta, retain customers. Now it's starting the job. The job started. So processing first batch. So there are 8 customers and 700 orders. And it writes. So data is written. Hmm. Oh, actually, something went wrong actually with SQL. Okay. Well, yeah, so it has written to customers and orders, but yeah, actually there is some. What happened? What happened? Well, there is very obscure error from Spark. Something that I haven't seen before.
But you know, Kirill, this is exactly what people are interested in. So to see you failing and then seeing how would you approach this in real life. So like in your job, what would you gonna do now? For example, you gonna try to go line by line and find like the main error, yeah, the first one that was raised. Or for example, you're gonna just copy and paste it to ChatGPT and
Yeah,
that's
that's
like
a
what the
good
hell is
question.
going on? I never seen it. Yeah. So I mean, how
Yeah,
would you approach it? Seriously, tell us.
that's the second approach would be, I think, the best. Yeah, just copy and paste it. But it's something. So it seems like it's error with what some reason with so it's error with it's inside Spark. So I think it's something probably wrong with actual SQL. Maybe I changed something. I actually added recently this thing, so maybe I have added something wrong. So the only way to test it is to run it. So maybe actually let's try just to remove. Oh no, I don't know what to remove. Well, yeah, we can. The easiest way is just to paste it into ChatGPT and see what it can do. Or
But I mean, for example, I mean, like, Kirill, can we just, for example, make SQL like super simple, like much
yeah,
simpler, for example, and see if like the very simple SQL gonna work?
yeah, let's do a simple one. Let's copy it and tell that just do aggregation. So paste. So customer name, created at membership. Yes, actually it's not needed, but okay. So we have yes, and then I select customer orders, inner join these customers, and then we make aggregation count distinct. Maybe count distinct. Something wrong with it. Maybe. Okay, let's for now. Yeah, let's do this. Maybe even just to let's yeah, just remove it. Let's see just total orders for customer. This one should work. Okay. Now let's replace it and run again. Okay. I need to restart it. So here I will just restart it. Just one container called Spark Submit. Through this container, we submit Spark jobs. Okay, it's restarting. just need to restart it because we changed the code, and when we spin up container, it copies the code inside there, so we need to restart it. So it will see the latest changes. Okay, and now let's execute the same command. Yeah, I think something was with my recent changes probably. Okay, so started batch 0. Yeah, again, so it's so you can see if it will be successful previous batch, you see the same data here because it haven't finished successfully. Okay, so it's running. Oh no, actually no. Yeah, the same error expression. I have no idea what it is. Error
So,
occurred.
kiddo, time for ChatGPT, yes? Or what you use in your company. I mean, also share with us these insights. So, what are the AI tools that you are using?
Just this cursor. So this cursor, and here we have this chat here. That's
Okay,
basically.
so meaning that you even don't need to go to ChatGPT, yeah, but you can speak inside this cursor because it holds your code as a context already, yes?
Yeah. So let's try to paste this error.
Hey, Kirill, how much it costs? Very nice AI tool. How much do you pay?
I don't know.
You don't know company pays,
Paid,
yes?
I hope. I think it's the same as ChatGPT. It's $30 per month or something like this. I don't know. Something like this.
Okay. Superb, superb. So we all need to work in gambling, yes? So everything is there for free. That's good. That's good.
Okay.
So they make money on usual people, but who work inside, they benefit a lot. Oh, good.
So let's paste this error and see. I suspect that something. No, I think because I just added a few calculations, but before it worked. So maybe it's something with. Okay, so it has an idea. No such method error. Ah, okay, mismatch of version.
And you were advertising Docker so much, yeah, that there we can specify everything and it's gonna work. So basically, even this can occur. Okay.
Actually, it's strange because no, it didn't solve, I think, the problem. No, I think it's just made up because I already did this thing what he did. So it's already different.
But I mean, Kirill, tell us please how it's working now. So what it does, so it is on the right. It is like making this reasoning, yes. So it is trying to understand what's going on. But then would
Yeah.
it automatically somehow change your code, or
Yeah,
would
it's
it
just
just give
changed.
you suggestions?
Yeah, it just changed. You see this green
Ah,
thing?
so this is already what it edited, really?
Yeah. So because it's in agent mode, but you can change
Oh,
it to ask, and then it will just write to you. But in agent
okay,
default,
okay, but you
right?
really gave to it like the full permission to change your code with this
Yeah.
agent mode, yes?
Yeah, exactly. So
Ah, okay.
small cursor. Yeah. So quite convenient. Yeah. So I think no, it actually doesn't make sense what it did here. It's the same as here. Free.
Okay, but can we try? Maybe it's gonna work, no?
Kafka free. Ah, okay. It's decided to use 3.1. Okay, let's change it here as well. this version. And okay, maybe let's try. Maybe it will work, but I'm not sure. Because it already worked before, so why to change it again? Okay. But if you
You mean it worked before, but I mean it didn't work now. So you're saying it worked before, like how many ages ago it worked?
Oh, yesterday, yeah.
Yesterday. Okay.
Start now. A few more nodes. Master and worker one. Okay, let's restart this. We'll just restart few, well, all Spark related containers. Actually, there is a command restart also. Nice. Small suggestion. Instead of what I'm doing, we can do run restart. Not this command. All right. Okay, it's
So
restart.
what you are doing, is it wrong or what? So like, I mean,
no.
without this restart?
No, just here I run this complex command down and up, but this ChatGPT suggested restart instead. But doesn't really matter.
But its suggestion is smarter, yes? So it would have required less time, I guess, because now you are making this down and up like the fool.
I think it will be the same. No, I think.
Okay. Guys, let's test at home. Let's see if like what Kirill is saying true or not.
Okay, let's see. I think it will not work. I'm not sure actually why. Maybe I'm wrong. Okay, so far the same as before. This warning is okay, doesn't matter. Oh, okay, no, it worked, okay.
Man, come on, and you were saying that you think it won't work. Hey.
Okay. Okay, we fixed it with help of not ChatGPT, with Claude. Yeah, it's actually Claude.
So under Cursor, they have Claude, yeah, model.
Yeah, but you can change it, but this is just default one. I haven't changed it.
Oh, you can even choose them. Okay, tell us, why do you use Claude?
It's for code, it's actually clever. For writing code, it's very clever. I think of all of them, he is the most clever one for code. And
okay.
Yeah, not only I think like this. So yeah, so now, well, yeah, now we have simpler query, but you see that it's finished and it's actually continued to write to process data. So it was our initial 0 batch. It finally finished. And as I said, so it's using checkpoints. So it knows because it was failing before, it is now restarted from the same failed part. And now it continued with batch 1 because there are more orders appeared. Yeah, so you see this, so how many orders I did so far. But it doesn't match, right? So there are only 700 orders, but it says that there are thousands already. It's because of our error actually. So because we tried several times and our job failed on this part. Where is this go? Here. Yes. It's actually, I didn't notice. Yes, it's fine. So it failed on this part here. But before we have written already this new customers and orders several times already. and it started back from checkpoint again from previous. So you see, it's like duplicate. So now we have duplication of data, which is better to get rid of. But in our simplified example, well, it was not expected. So, but okay, just an example, like when we're dealing with this streaming applications and Kafka, we always can have possibility when we have some duplication of data, so we should be extra cautious about it. Well, now you see, so it's
But
running.
sorry, Kirill. Sorry. So how could we have avoided this thing that we were now trying it several times? How we could have now started from scratch and remove all this stuff to make sure that it is all clear?
Well, yeah, what we can do, usually we just can, well, stop the streaming. So let's you see, it's, yes, every 5 seconds there are 2 more orders, I think. 5, somehow, like, so it's not stopping. So let's stop it. Yeah, it stopped. After we stopped it, so data is left in these folders. So let's go back here. So we have here user. So this is our tables, and so here is duplication of data. The simplest approach is just to, well, drop the whole data and replay it again from Kafka. So just how it's, or more sophisticated approach will be to try to, well, we can either write in code that we would like to, even right here, for example, we can add additional step, because here we read data. Where it's happening? Yes, here we read again data. So we can add here additionally step like drop duplicates or something like this. But it will make more, like, it will affect our, well, performance as well. It's just we need to decide what we will like, more better, like, let's say more robust solution from code, or more faster solution. So so if we just would like to clear all the data, it's also fine. So we just go to again to data, and we stop the streaming, so we just drop them, and that's it. They're gone. And we also should remove checkpoint. So as we've seen, we've done already, how many are clear? It was about 15 batches, right? It's already done few, but it says all this information about this. So if you open this, you can see here some other folders called commits, offsets. It saves this what we already listened from Kafka, from topics from here. So where we stopped here listening for them. So we can just, if we want to start from very beginning, we can just drop this again, this checkpoint. So it's called retention stream. And it will not find, and we will start again the job. It will not find it, and we'll create a new one, and we'll start again from where we specified. It's specified here, or starting offset earliest. So it means that it will start from a very early time in Kafka, the most earliest that's possible. Let's see. Okay, so it started, and yeah, so you see now it's batch 0 again, because it's totally, we wiped out all the checkpoints.
Okay, and now it is like 993 orders, and we should see only them.
Yeah.
Okay, let's check it. Let's wait.
Well,
who is good in quick calculation? Is it 993? Blah, blah, blah. At least it is free in the end. If we sum up, it's going to be free in the end. These are good news. Okay, nice, Kirill.
All right, so
Cool. No, seriously. I mean, exactly. These are the things that, because I mean, now imagine, just to let you know that guys, in couple of weeks, they gonna be showing their final project. So perhaps today somebody, after like watching the lecture, would think like, wow, great. So I want to do project of streaming, and then they need to understand, yes, so how to test it, how to like restart it, then clean up. So I mean, this is very useful. Thank you for showing it.
Yeah, okay. Unexpectedly went through debugging process. Yeah. Okay.
No. But I mean, again, and Kiro, I mean, now when you were like scrolling through this, I guess that you also see that your lovely friend has changed some code even here. Yeah, if I understand correctly, like how I can interpret it.
No, yeah, it's actually it's just so it changed. Yeah, you see here. Yeah, move you to the left. After, yeah, if you mean the cursor, right? It's
Yeah,
right.
exactly.
Yeah, it writes here what was changed, and you can go through it like through Git in the
Ah,
history. You can even
okay.
undo what he suggested.
Very
But
smart.
yeah, we'll keep everything. So
Of course, because we have seen that it solved the problem. Yes, so that's why we fully trust it.
yeah,
That's it. Okay.
yeah. So it's like this. Um, yes. Um, well, so far, if there are any questions, or anything. Okay. Okay. So we have
Can I
set up
try?
this.
Can you hear me?
Yeah.
This what is it called? Debezium. This like a listener on the database, and every interaction is forwarded to a Kafka. So it's a service that's running by itself somewhere in its own Docker container.
Yes. Yes, you are absolutely correct. So it's in Docker. It's just another container. So we have here Kafka container. It's configuration of Kafka. And here's this one. Yes. So it has its own. It's called Kafka Connect because it's how they have the terminology in Debezium. So
Okay.
it's just another process that connects to Postgres and forwards this all events from Postgres to Kafka. So it's intermediate layer between them. Yeah, that's Debezium.
Okay. And it provides one topic per database, or you have to configure this in the Docker file?
Yeah, it's also configured. So I haven't went through these details, but here we have here folder Debezium, and here we have configuration for it.
Okay. I don't see that one.
So
Yeah.
so it says here information about what we are going to it's going to be connected Postgres. Also, well, information about user and password. So without it couldn't connect. And how it does it, it also says here that it should prefix it Postgres. So we see in topics
Okay. Yes.
here their name Postgres because we specified it here. And we specify some default strategy that it should be JSON format and well something else. So some standard configuration here. Yeah.
This part I was missing. Thank you very much. Okay. And you mentioned in the beginning you also use Infinispan. Is this coming up, or did I miss that part where that's already part of your demonstration? The
Sorry,
in-memory database, Infinispan, I think you had listed in the tech stack. Or maybe I misread. In
sorry,
the
but
in your PowerPoint, not PowerPoint slide.
Yeah.
I think you mentioned part of the stack you use InfiniBand, or maybe it's just a possible option and you don't use it.
Yeah, it's another option which is almost Elasticsearch, but we don't use it. It's
okay.
This I copied from official website, so they show as an example. But we are using here. It's just our third option data warehouse. This is our thing here. Yeah, we don't use anything.
Okay, thank you.
Yeah. Right. Okay. I just wanted to finish with some with our case scenario. So we already have, so we have some calculations of it. So we already stored in Delta table. So we have everything in place in this HDFS, right? But then later on, we would like also to make analytics on top of it, right? So now we have some solution, but we would like to make sure, is it working? Is it like, does it really make difference or not really at all? For this, we would like to run some analytical queries on top of these tables, right? In this case, it's I haven't included it in this code here, but it will be then very complex then. But I will just tell that the final step here will be just then to get this data from HDFS, and we can copy then these tables. They can be reused anywhere. So it's Delta format. So we can copy it over to, for example, cloud storage. That's, well, in my case, in real case scenario, it was the case that we copied to cloud storage, and then on top of it, we can just connect to it from most of the databases. We can connect it to it from BigQuery, for example, and we can start making SQL queries and check, okay, so this is how many customers were at risk, that's how many were found, and so on. So this is just final step for this, is just to have some analytics on top of it in order to make maybe A/B testing, right? So we can split it. I included this in the first complex query. I can even maybe start it again, but so here we can, for example, make like test group. We can make, well, here is very simple, stupid approach how to split it. We can do it just split by customer ID and split into two groups, treatment and control, and then decide on them what to do with each of them. But yeah. And later on, as I would like also to say, so this was just one approach, right? So with one, so we have Spark, we have this HDFS name node with Postgres, but on top of it, again, we are not limited to only Spark or I don't know, any other like Flink. So when we have this thing in place with Kafka, with streaming platform, we can build additionally anything else on top of it, and we will not make any disturbance to the whole system. So we can add more Spark jobs, right? We can make them run in parallel. We can connect to the same Kafka. We can even make a separate data warehouse the same way. So as just to tell as an example, so this was a case. This was based on one real task that I was solving, but also, for example, we are using, in addition to Spark and BigQuery, we're using BigQuery for data warehouse. Addition to this, we also using ClickHouse, for example, another data warehouse, which is quite fast, and we really like it. So I also mentioned it here. And for example, the final case for this solution will be for us maybe even to switch it over fully to ClickHouse, for example, and make it less worry about infrastructure, managing Spark, but it's always, well, depends on use case, what is easier or what is preferred. So in this case, Spark was very preferred. Yeah. Okay. So this is what I wanted to tell so far. I think we might want to get some small break maybe.
Kiro, I mean, just to understand, so that you also prepared for guys some interesting tasks, yes?
Yeah, well, I suggest that maybe we'll start them. I don't know. Well, we can start. My plan is to start doing them like on workshop, right? So I'll just share this project with you, and there are some tasks, and then we can do it together and see how it goes. But well, I suggest to make some like 15 minutes break. So if now, if you have,
Yeah,
if you
I
want
mean,
to.
exactly. So, I mean, first of all, let's say many thanks to you for this lecture. I think that at least I found out that having Cursor, then you're gonna be a gorgeous developer. So this is my main outcome. But I mean, then also you see, like, how to say, you also analyzed this response. Yeah, you just didn't blindly trusted it. You look like, okay, what is here? Ah, okay, maybe version, yeah, maybe it might work. Okay, but I think this would not work. Yeah, we have seen that it worked. Yeah, so in the end, I mean, obviously, you never guess unless you run. This is, I think, the main motto of developers. Okay, so exactly, many thanks to you. So let me